Okay, we are recording. This is Unit 3, Lesson 3, Part 1, Solving Quadratics with the Quadratic Formula. So in this lesson, we're going to introduce the quadratic formula, kind of see why it's necessary, what it does, what it's good for, what it's not good for, and in future lessons, we'll explore in a little bit more detail what we can do with the quadratic formula and when we should be using it. So I wanted to start with a review of current strategies. So what do we know about quadratics already? Well, we've covered two strategies for solving them. One of them is factoring. We spent forever on just getting the factoring down, and then we looked at how we solve quadratics using factoring. And then in the last lesson, we looked at solving quadratics by square roots. So with factoring, you set one side equal to 0, okay? And then you factor the other side. And that allows us to use the zero product property, abbreviated ZPP there. So you need to have a 0 because 0 product property, and then factor because product. And so you need your 0, you need your factors, because that key idea is that if you have multiple things that are multiplied together and the product is 0, then one of the factors in that string of factors had to have been a 0. So you got to get the 0, got to get the factors, use your 0 product property. Solutions will correspond to the zeros on, I love it when I see a typo while I'm recording, on, that's the word on right there, on the graphs, that is the x-intercept. So remember that zeros, x-intercepts, and roots are all the same thing, okay, completely synonymous. And we've explored that, okay, where you can factor, you find the zeros, you can graph them, and you can see them. They are the x-intercepts. Now with square roots is one of those strategies that is not always covered, and the main reason it's not always covered is because it only works when b is equal to 0. So for example, if you had x squared plus 3 equals 4, okay, there's no b value in that. And just in case we're not remembering, you have ax squared plus bx plus c. If that b value is 0, well, 0 times x is just 0, and you're left with ax squared plus c, and you don't have that x term in there, okay? So that's what we're referring to when we say that. It will show imaginary solutions. So if there are imaginary solutions to it, you will get them with the square rooting. You will not get those with factoring. And the imaginary solutions will not be visible as x-intercepts. And that was the extra credit that you had. You had to produce that conclusion from the extra credit that was given. Okay, so right now in the lesson, I want to take some time to do an exploration. So if you're doing this from home to make up the lesson, I do want you to pause the video in these parts and work this out with whatever you're taking notes on, and you should be taking down some notes. Okay, you don't have to copy down everything, but the key stuff, the examples, and in your notes, I want you to work on this. I want you to graph that particular equation, x squared plus 2x minus 5 equals 0. And I want you to notice something about the x-intercept. So pause for a moment and take the time to actually do that and take a look at the x-intercepts and just make some observations. There's not anything like correct that you're supposed to say. Just make some observations. Okay, now try to factor the left side. So try to come over here and get the x squared plus 2x minus 5 factor, and then think, what do you notice? I have a cat that's like running amok, is running around my apartment. So what do you notice? What do you notice when you try to factor it? Okay, and the point of this exploration is just to make some observations, not necessarily to draw some conclusions, but to maybe give you an idea of what might be happening. Where do we want to go with it? Okay, so once you've had a chance to explore, we do want to make sure that we kind of come back together and draw the conclusions that we need to draw. Not every quadratic is factorable. And so while factoring is a great strategy, and in fact, I would say it's the preferred strategy, it's not always feasible. Like not everything can factor. So when you looked at that problem, and I forget what it was like x squared plus 2x minus 5, I think, something like that, or plus 5, I don't know. But this one won't be either. So when you go to factor it, you start looking at, okay, well, I need some factors of 5 that will multiply to give me a 2, or add up to give me 2. So factors of 5 that will add up to give me a 2. And they don't exist. Okay, so you got 1 times 5. Well, you could add those, you get positive 6. If they're both negative, you get negative 6. You get like a 4 if the 1 was negative 4, but you can't get a 2. Okay, can't get one. And yet, when you look at that on the when you graph it, you realize there are x-intercepts there, but we're not going to be able to find them with this particular strategy. And so the goal of that exploration was to really get you thinking about what kind of answers you have. And we're going to come back to that. That'll be in probably the next lesson. That what kinds of numbers can you get for your answer, and then what do those look like on the graph? How does that show up when you're factoring? Make some of those connections there. So what is the solution to this problem? Not everything is factorable. Well, the solution is something called the quadratic formula. I have heard people call this the quadratic equation, and I really don't like that. It is a formula. It is maybe the only time this year that I am just going to give you a formula and not try to explain or justify where the formula comes from. Now, it does come from somewhere. It is not made up. And I know I have some videos on my YouTube channel where I derive the quadratic formula, and you have to use another process called completing the square, which you could probably understand even if you didn't have to carry it out yourself. I might link to that video if I can find it, or just I'll make a separate one for those of you that do want to see where this formula comes from. But most students typically aren't interested in where it comes from. So here's what the formula is, and you'll notice I'm going to say this the way I was taught to say it in geometry. So x is equal to, because remember, we're using this to solve an equation. And solving means you're looking for solutions, and solutions are the values of x that make the equation true. So when you're using the quadratic formula, yep, it starts with x equals, because that's what we're looking for. The quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, now typically this formula is provided on most of your reference sheets. I was made to memorize it. I was actually what did Mr. Oakes say he was going to do? He would make us stand in front of the class. We'd have to stand up and recite it. So that was terrifying, and I learned it. He is the one that kind of drilled home for me the opposite of B instead of saying negative B or minus B, and it just reinforces the idea that whatever B is, you're going to take the opposite of it. Now, there is a story that a former teacher at AC used to use to teach the quadratic formula. There's like all kinds of songs and stuff, but the story goes like this. A negative boy couldn't decide whether to go to a radical party or B square. So he missed out on 4 awesome chicks because it was all over by 2 a.m. Kind of a brilliant story there. It is descriptive, not prescriptive. So nobody should be going to a party at 2 a.m. No one. Okay, go home, go to bed, get a good night's rest, get up and run in the morning. That's what I would do. But the way the story works is a negative boy obviously corresponds to the minus B, or the opposite of B. Couldn't decide, is that plus or minus? Okay, so you do have the both symbols there. Whether to go to a radical party, so that another word for square root is a radical, or be square. Being square is a word that my dad has said. Just to be square, it means like be uncool, be unpopular. Be square. So he missed out. So the missing out is the minus sign on 4 awesome chicks. I think that's pretty straightforward because it was all over, and the all indicates that the fraction bar goes all the way across, all over by 2 a.m. Okay. Now, this is not my favorite formula. We've got that indecisive plus or minus. We have a square root. We have a couple negatives floating in there, and the whole thing is a fraction. What could go wrong? Okay. Now, I want you to note that A, B, and C are numbers. So never, ever, ever should I see something like A is equal to x squared. Nope. A is not. A is not equal to x squared. A, B, and C are only ever numbers. Now, those numbers could be 0 if you don't see the B or you don't see the C. Okay, then it probably means it was 0. It might mean that they are 1. So if you just see the x squared but you don't see a number, it means A was equal to 1. All right, but there's never any situation where an x turns up inside the body of the formula. Okay, nope, nope, nope. You're just going to take numbers, get plugged in there. All right, so let's take a look at the pros and cons of this awesome formula. Under the pros, the biggest pro, and the reason that we do have to teach this, is that it always works. Okay, always works. The quadratic formula will work for any quadratic like ever. It'll work for the ones that you can factor. It'll work for the ones you can't factor. It'll work for ones that have imaginary answers to them. The quadratic formula always works. And so it's in theory, if you need to solve quadratics, if that's the only thing you needed to do, you could just learn the quadratic formula and be done with it. That's not the only thing you do with quadratics though. So we do have other strategies. It's also mechanical. And by that, I mean, you don't have to think super hard to do it. You're going to identify the A, the B, and the C, and then you put them in the right spots in the formula, and then you have to get to the end. And so there's not a lot of thinking or decision making like there is with factoring, where you have to sift through the numbers and then choose the numbers that you want. Now for cons, and these are big cons, it is very prone to errors. Okay, so I can say it's mechanical. You take the A, the B, the C, you put them in, and then you just get the answer. Except going from the putting them in to getting the right answer, there's a bunch of things that can go wrong. I mentioned like a minute ago, you know, you've got the pluses and the minuses, you've got a square root, you have a fraction. There's just lots of places where you could make mistakes. And it requires a good grasp of arithmetic and order of operations, because you have to be able to navigate from the beginning to the end of that. You've got to be able to square numbers, multiply numbers, add and subtract them, divide them without making errors. So you have to have the arithmetic skills, and you have to know which operations to do in which order in order to get to the end of the problem correctly. So that makes it just very cumbersome to use. You do have to attend to what you're doing. So for an example, so I have there problems that can be factored generally have nice solutions with the quadratic formula, and it makes them good for a first example. Okay. Now, typically, if we are able to factor something, we're going to factor it. Okay. If it is factorable, we're going to try to get it factored. But you can solve factorable problems with the quadratic formula, and they usually come out really nice, meaning that some of that arithmetic issues are nicer to deal with. And so for a first example, it works pretty well. So remember, to factor, you have to have that 0, because we're going to engage the 0 product property. So what I'm going to do here is I'm going to subtract 7x and 15 from both sides. Okay, so that's supposed to indicate that. So we have 2x squared minus 7x minus 15, and then we have the 0. Okay, and now to engage the quadratic formula, I need to identify A, B, and C. I don't know what I was thinking. Why did I pick this? It's awful. All right, So A is equal to 2, B is equal to -7, and C is equal to -15. Okay, again, if you didn't see, like let's say there's no x and it just has 2x squared minus 15, B was 0. If you see just an x squared, okay, A is 1. And then you do have to remember that those negatives are a part of it, which is why you have to have it in the right form. So if you leave it like this and you say +2, +7, +15, it's not going to work because you're going to have the wrong signs on your numbers there. Now, the quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. That is squaring right there. And now we plug them all in. So you know that I say the opposite of b. I don't say minus b or negative b. I say the opposite of b. So let's go check out b. B is -7. What is the opposite of -7? +7. Plus or minus. Now, b squared, I'm going to tell you always, 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 always put that in parentheses because that is going to be one of the common mistakes. What was A was 2 and C was -15 all over 2 times 2. Now, practically speaking, sometimes you can do pieces of this in your head. So for example, if you know that -7 is 49, -7 squared is 49, you might just opt to skip right to the 49. If you know 2 times 2 is 4, you might just opt to write the 4 there. Typically, if I'm going to be grading or evaluating any of your work on the quadratic formula, I want to see this, though. I do want to see that you can get the right numbers plugged into the right places. Now, from this point on, it's a bit of a free-for-all, okay? So you've got certain things you have to do in a certain order. You can square at the same time that you multiply because they're separated by the subtraction. So order of operations says you would do the squaring first and then you would do the multiplication, but because they're separate, you can get away with doing them at the same time. Same with the 2 times 2. Okay, so this would become 7 plus or minus the square root of 49. Now, this is where it gets tricky. It is -4 times 2 times -15. Okay, so you have a negative times a positive, which is a negative, and a negative times a negative, which would give you a positive, which means that is going to be a plus sign. I'll repeat it one more time, okay? Negative times a positive gives you a negative, and then take that negative and multiply it by this negative, and you will end up with a positive. Sometimes students will say, but wait a minute, this is a subtraction sign. Okay, like fair enough. Positive times a positive is a positive. Positive times a negative is a negative, and minus a negative would give you a positive. Okay, you're going to land at the same spot either way. Now, this is where I'm questioning my life decisions. I'm going to do 15 times 2, which is 30, and 30 times 4, which is 120. Over 4. Okay. So this becomes x is equal to 7 plus or minus the square root of 169 over 4. And this is what I meant when I said that the ones that are factorable have a nice answers. So if you get to this point and you actually do get something that you can take the square root of, that's your tip off that you could have factored it. Okay. And so the square root of 169 is 13. And now we run into this issue where like, okay, we have this plus and we have a minus. Okay. We can only do one at a time. So we have to split the problem in two, where you're going to have one that's going to be 7 plus 13 over 4, and the other one's going to be 7 minus 13 over 4. 7 plus 13 is 20, and 20 divided by 4 is 5, so one of the answers is 5. The other one, we have 7 minus 13 is -6 over 4, and that simplifies to, like, I'm going to go with negative 1.5, but it would typically be negative 3/2. Okay, now if you get all the way to the end of that problem without making a mistake along the way, and you have these nice answers, so you have answers like 1.5 or 5, what that means is that the problem could have been factored. So it's actually, the tip off is right there. If you have the square root and it's something you can take the square root of and get an integer, that means that if you go back to this problem here, you could have generated factors, okay? So that's my iPad dinging. Okay, so that's what it looks like with the quadratic formula. Pause it if you need to. Definitely want to write that down. And then we're going to talk about it on the next slide. Where do mistakes happen? So when you are dealing with the quadratic formula, where does stuff go wrong in this? So here's the top mistakes. A sign error when you're squaring the b, okay? And I mentioned earlier that if b is negative, we'll just say -3. What a lot of students will do is they'll do that. They'll be like, -3 squared, except that is wrong. And if you put that into your calculator is going to spit out the wrong answer, but you're not going to know it's wrong because you're going to think it's right. Okay. And it has to do with order of operations. -3 squared means -3 times 3, and your calculator is going to tell you -9. But that's not what we want the calculator to do. What we want the calculator to do is b squared, which means it's got to do b times b, which means we want -3 times -3, and we want a +9. So that's why I said when you're squaring, always put it in parentheses. Now you only need to put it in parentheses when it's a negative, but if you just always put it in parentheses, you won't forget to do it. Second one is a sign error with the -4ac, and that was one that, like the last slide, I explained it 2 different ways. Okay, and so when a and or c is negative, it's easy to get the sign wrong because you have the negative right here, and when you combine that with another negative and possibly a third negative, so when either of those or both of those numbers are negative, I just see a lot of not getting the right operator there. Okay, this is like a tricky spot. And errors when simplifying the square root. So the one that I just did, we had like the square root of 169, which is 13, which is really simple. But what happens when you get like the square root of 12? Okay, and it's not something that you can take the square root of. So then you have to go through the simplifying process. And then errors when simplifying the fraction, and that can get very messy as well. And because it's a math class, you're expected to leave your answer in a simplified radical form and not a decimal form. And so you can't just dump the whole thing into a calculator, because the calculator is going to give you the decimal, and that's not going to be what we want. So those are the common spots where I see students make mistakes. The more steps you take, the more you're willing to write down, the fewer of these you'll make. It's usually when students start to like try to skip a lot of steps that it becomes more of an issue. We can use Desmos to mitigate these errors. Okay, what that means is just we can't alleviate all of the things that might go wrong, but we can use the calculator features of Desmos to mitigate. To mitigate means to lessen or to make less significant. Now, for now, we will use Desmos to evaluate just the b squared minus 4ac. Okay, just that part of it. Now, we can use Desmos to do the whole thing. Okay, it takes a little bit of practicing to dump the whole thing in, but for right now, we're just going to use Desmos for the b squared minus 4ac. That's also called the discriminant. So let's go back to the original example. This is the one from the Explore. And what I'd like you to do is start by setting the formula up, okay? So we have x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And we have a is equal to 1, b is equal to 2, c is equal to negative 5. So for my setup, I have the opposite of b, which is 2. So the opposite of 2 is negative 2, is equal to 2 squared, plus or minus the square root of 2 squared, minus 4 times 1 times negative 5, all over 2 times 1. All right. Now, I am okay with some shortcuts there. I really am. Like, I don't see any compelling reason why you need to write 2 times 1. Right. Now, what we're going to do in this example, because like I said, we can use Desmos to different extents, and there's a lot of flexibility in how far a teacher might want you to take your answer to consider it simplified. But for now, we are just going to dump in the b squared minus 4ac. So that's this part right here. So I'm going to do 2 squared minus 4 times 1 times negative 5. Now, I am okay if you want to say 4. I am okay if you want to leave out the times 1. All right, absolutely okay with that. Just be careful. Just be careful. And if you find you're getting stuff wrong, please just err on the side of doing a little bit more. Now, what that tells me is that is a 24. So what I'm going to keep for now for my final answer. All right, I clicked out of the slide. I just hit something at the bottom and I can't go back. It's gonna fill up the next slide too. But I stopped right at the end and now I don't even remember what the problem was. It was what was it? X squared plus 2x minus 5 equals 0. Okay, I really hope that was it. And so we had, I didn't want to leave without finishing that problem. So we had the opposite of b, plus or minus, and then what we used Desmos to do was we used Desmos to get that 24. For now, I am okay with you stopping the problem there. Now, this actually does go further, okay? So what I'm going to do is like star it, okay, and say, listen, for now, you can stop. But it does go further. And you can see where people might make mistakes. So the square root of 24 actually simplifies into 2 root 6. And then you will see that you've got some common factors of 2 going on here. And so the algebra behind that is you would factor out the 2, and it's going to leave you with that, and then the 2's are going to cancel out. And so your final answer is x is equal to -1 plus or minus the square root of 6. Okay, and here's the deal. This is what you would probably see as a multiple choice answer choice. And there's just so many places where you can make a mistake. So for now, I want you to stop right there. And then we're going to work on some ways that we can get from here to here in the least error-y way possible. Okay, so don't panic at this point. Now we're going to see what the next slide is going to do. Okay, I had to retake it. So this one I want you to try. Okay, so I do want you to pause the video and actually try to work this one out, and then I will talk about it. Like we'll kind of go over it in the video, but the problem is x squared plus 4x plus 29 equals 0. So I want you to set up the quadratic formula. I want you to use Desmos to find the b squared minus 4ac. I want you to simplify it as much as you can. When you've gone as far as you can, I want you to take a look at the graph, but I want you to use a y instead of a 0. So I want you to write x squared plus 4x plus 29 equals y instead of 0. Now, if you think about what x-intercepts are, x-intercepts is where y is equal to 0. Okay, it's just going to give us, it's going to allow us to see what the parabola actually looks like for this problem. Okay, so pause the video and take some time and work that out. It's going to be different. I'm not expecting you to like arrive at some grand conclusion, all right? I just want you to see how far you can take it. Can you figure out what's going on in this video, or not the video? Well, that too probably, but in this problem, okay? So pause the video and take some time to work your way through this. All right, so in setting up the formula, you should have had something like this. X is equal to the opposite of 4 plus or minus the square root of 4 squared minus 4 times 1 times 29 all over 2 times 1. Okay, I know that's super messy, but you should have it written down on your own page anyway. So -4 plus or minus the square root of 4 squared, that's a 4 squared, minus 4 times 1 times 29 all over 2 times 1. Okay, so that's what you should have for your setup. Now let's check out what Desmos does. Okay, so we're going to use Desmos for that 4 squared minus 4 times 1 times 29. And what you notice is that we have a -100, okay? So going back, simplify as much as you can. So we're going to have like x is equal to -4 plus or minus the square root of -100 all over 2. Okay, the square root of -100. Well, that is the square root of 100 times the square root of -1. That's 10i. So -4 plus or minus 10i. And then over 2. And then what you can do is you can divide everything by 2. Okay. I just do that vertical line there to separate it off. So this would be -2 plus or minus 5i. All right. Now, I don't necessarily expect you to have gotten that far. So if you only made it as far as like here, okay, that's fine. If you made it to the 10i, you have a 10i floating around somewhere on your page, totally fine. If you made it this far, awesome, okay? If you made it all the way there, I'm kind of wondering if you've done this before, okay? Because that was a little bit further, but hopefully you were able to make it to about there. And then you recognize this isn't quite the same thing that we've been looking at, okay? Because that's got that -100. So what I want the last part of this to be is to check it out in Desmos, except instead of using a 0, I want you to use the y, okay? Or you could, yeah. So like looking at that, it disappeared. When I put the equals y in there, I still should see it. Why do I not see it? I need to see more of it, and it's like underneath here. Let me think. I think I can turn my camera. All right, so the next slide, the only slide left, is there is no homework because I think I got far enough in this that I could give you some stuff, but there's some more stuff that I want to explore. And just due to the circumstances under which I'm recording this, I'm not sure that that's like the best idea to pursue right now. So, if it's a B day, be sure to work on the posted assignments for the next 2 class periods. A day, yeah, it's not going to be an issue. We're not going to do this till after the other assignments anyway. So, all right. So, hopefully this was a good lesson, got you caught up. You know what's going on in class. As always, let me know if you have any questions.